So hello guys. So in this video what I want to do is I want to go over this problem. Now before I get into this, I do want to kind of write down some formulas here that I found online, or some properties really, because when I was doing this, it kind of, I guess, it tripped me up a little bit, but basically we're going to use the following problems or the following formulas, and so if given, and I'm going to just write this down in pen. Oops. So we're going to go ahead and just write this down in pen. If given infinity, so number 1, infinity over a, over some number a, let's just kind of such that a is greater than 0, right? So we're going to kind of grab this, and then infinity over a is really just going to equal infinity. And number 2 is infinity over a. So if we're given infinity over a such that, again, such that a is less than 0, right? Such that a is less than 0. A is less than 0. Then infinity over a. Infinity over a is actually going to be negative infinity. And then number 3. Number 3 says if we're given negative infinity over some number a, such that a is greater than 0, such that a is greater than 0. And notice there's a negative here, right? Such that a is greater than 0, then negative infinity over a, which is the same thing, will give us negative infinity. Now the last part is, if we're given negative infinity over some number a, such that a is less than 0, a is less than 0, then this is really going to be negative infinity over a is going to equal to infinity. So we have to be careful with how we do this one, and also we want to always divide by the how do I say it? By the degree of the highest degree of the denominator. So in this problem, I'm going to write down again the problem that we have here, the limit as x approaches infinity. So let me just kind of write it down really quick. Give me 1 second, guys. Okay, so here, so we have this problem here, and we're going to find the limit as x approaches infinity of this. Now, there are a few things that I want to keep in mind with this, because in reality, and obviously, we always knew that when we have, so you're always going to go divide numerator and denominator by x term with highest power, I think, with the highest power. So here we have the square root of 2x squared minus 1 over, and on the bottom of the, in the denominator, we have an exponent of 1 for x, and then it's going to be minus 3. So what we're going to really do is we're going to divide by this part, x to the first power. So really, how this is going to look, and we have the limit as x approaches infinity of this will be the limit as x approaches infinity, and we're going to do the following. So we're really going to say, and it's going to go like this, basically. Let me think really quick. Give me 1 second, guys. So this is really going to be, we're going to divide by x on both on the top and the bottom. So we're going to say the following, this. So 2x squared, the square root of 2x squared minus 1, which is the top, and we're going to divide it by x. So if my hand is shaking, guys, I do apologize. I don't know why. It is really difficult to write on this thing. So divided by x, right? And then all over, and it's gonna be 4x over x. So really, it's gonna be 4x minus 3 all over x. So then we're going to get the following, and obviously, let's see here. Hold on, guys. How did they do it? So then after this, we know that we can basically make this into one radical. So this is going to equal the limit as x approaches infinity of, it's going to be the following. And if I write x, so if I write x as a radical, x equals, let's say, the square root of a, and I want to solve for a, right? So I'm going to say this is going to be squared on both sides. And so I know that a is really going to be the quantity x squared, x quantity squared. So I can say that x is really equal to the square root of x squared. But this is only true such that x is greater than 0, right? For all real numbers that are greater than 0. So then I can say that the following thing for the bottom part, right? I can say that this is equal to the limit as x approaches infinity, and let me just kind of grab this stuff and just move it a little bit because I don't want it to take up a lot of space. So we're going to say the following using that definition. We're going to say this is equal to the limit as x approaches infinity of, and it's going to go the square root of 2x squared minus 1. So the square root of 2x squared minus 1. And again, this is the top of it. And on the bottom, we're going to say over, and it's going to go the square root of x squared. And so then we know that on the bottom part of this, we have 4x minus 3 all over x. And actually, what I'm going to do is I'm going to grab this part here, and I'm going to just change the color of it so that it doesn't look confusing to you guys, because I don't want to confuse anybody here into thinking that I just don't want there to be any confusions. So you see what I kind of did there, right? this entire part is really what this is, but it's only true such that x is greater than 0. So that's kind of the gist of that, right? Oops. And so then what I'm going to do here is this is going to equal to the limit, oh Lord, the limit as x approaches infinity. And it's going to actually be the square root of, and let me just kind of, it's going to be the following. Square root of 2x squared over x squared minus 1 over x squared. And this part here is really going to be 4x over x. Really, it's kind of like, so this turns like this, and this is supposed to be like this, and then minus 3 over x, of course, right? 3 over x. And so then what's going to happen is we're going to have the limit as x approaches infinity, and these two are going to cancel out, so it's going to be the square root of 2 minus 1 over x squared over it's going to be 4 because these cancel out, minus 3 over x, right? Like I said, this part kind of stays like this, right? And so then what's going to happen here is now we know that this whole part, and I'm going to take that off. I don't know why. This entire part is going to actually be, and we're going to have, so if you think about it, this is the limit, so it's going to be the following. It's going to be the square root of the limit as x approaches infinity of 2 minus the limit as x approaches infinity of 1 over x squared. So really, this is this part, and this is this part here, right? And then over, and it's going to be the limit as x approaches infinity of 4 minus the limit as x approaches infinity of 3 over x, right? So this is kind of what we have here. And again, you know, we kind of split it up into different limits here. So then we know that the limit as x approaches infinity of 2 is really just 2. So this part that's in purple here, it's just going to be 2, right? This is really what this is right here. And minus, and the limit as x approaches infinity of 1 over x squared. Remember when we had the limit as x approaches infinity of 1 over x raised to some power r, such that r is greater than 0. We know that this is really going to equal to, I think I said it was 0. I think I said it was 0, right? So really this is going to equal to 0. So we're going to put minus 0 here, and so this goes here, and then over, and it's going to be the limit as x approaches infinity of 4, right? This is really easy. It's just going to be 4, right, over 4, right here, and then minus the limit as x approaches infinity of 3 over x. The limit as x approaches infinity of 3 over x is really just going to be 0. So really this is going to be equal to the square root of 2 minus 0 over 4 minus 0, which is just going to be the square root of 2 over 4. And so this is our answer. And so we can finally say that thus the limit as x approaches infinity of the square root of 2x squared minus 1 over 4x minus 3 is equal to the square root of 2 over 4. And so this is our final answer. Okay, guys. So this is a pretty lengthy one. So if you guys do have any questions over this, please let me know. This one wasn't really that bad. You know, and also, like I said, if there is a number here that, you know, because I did go over these here, but that was only because, you know, apparently there were some that, that we were trying to do, and so, yeah. So with that being said, guys, I really hope this helps. And also, please like, comment, and or subscribe. And thank you so much for watching, and I will see you guys in the next video. Bye, guys.